Okay, Assalamualaikum warahmatullahi wabarakatuh and evening everyone.
Good evening.
Salam,
Yeah.
Waalaikumsalam,
Yeah.
Miss. Waalaikumsalam, Miss.
Yeah. Okay, so now untuk chapter 5, the name of this chapter is hydrocarbons. So hydrocarbons, we have two subtopics. One is alkanes, another one is alkenes. So hydrocarbon, can you please tell me what do you understand from the term hydrocarbons? We're not talking about the organic chemistry. Kalau organic chemistry, when we have hydrocarbons, apa benda tu hydrocarbons?
Molecules consist of hydrogen and carbon.
Okay, molecules consist of hydrogen and carbon. So basically, any organic molecule pun memang dia perlu ada backbone of hydrocarbons. Okay, untuk hydrocarbons, kita nak tengok carbon and hydrogen only. Untuk chapter lain, benzene, haloalkane, alkohol, carbonyl, adakah kita tak akan tengok dah hydrocarbon ni? Ke dia memang akan ada je selagi mana kita belajar organic chemistry?
Akan ada.
Akan ada sebab dia adalah the backbone. Okay, so it is very important and maybe agak lama untuk belajar hydrocarbon ni sebab dia the very basic untuk organic structure. So nak naming ke apa, kita akan start pada hydrocarbon. Even though for every chapter kita akan belajar naming lagi, tetapi tolong take note siap-siap apa benda yang sepatutnya basic steps untuk nomenclature, the naming of the components. Okay, let's start. So for hydrocarbons, kita tahu dia contains carbon and hydrogen. But then you need to know how to differentiate between aliphatic and also aromatic. Okay, aliphatic hydrocarbon tak sama dengan aromatic hydrocarbons. Aliphatic is the open chain structure. Open chain ataupun kiranya bukan aromatic lah. Aromatic ni dia kena ada certain criteria yang dia obey. Kita akan belajar lebih in chapter 6. But for now, you need to know itu je lah. Aliphatic ni dia bukannya ring. Dia tak akan form ring. Walaupun dia cyclic structure, tak semestinya dia ring, dia bukan aromatic. Dia belongs to aliphatic. Okay, so under hydrocarbons, the aliphatic compound that you need to know consists of alkanes. Okay, alkanes ni carbon and hydrogen connected by only single bond. Kalau cycloalkanes, kita cakap dia adalah alkane juga, ada single bond, tapi dia apa? Apa beza alkane dengan cycloalkane? Cyclo. Yes, cyclic structure but not necessarily a ring. Okay, so kat bawah ni kita tulis saturated. Apa maksud saturated? Sekejap lagi baru saya cerita sikit. Okay, so alkenes and cycloalkenes, still carbon and hydrogen, but then we have functional group present in this compound. Can you please tell me what kind of functional group present in this compound? Kalau in alkenes, cycloalkenes, apa functional group present? Kita belajar 4.2. Carbon double bond. Good. And they are classified as unsaturated hydrocarbons. Yang ni pun kita akan tengok sekejap lagi. Okay, the last one is alkynes. Okay, alkynes pun carbon and hydrogen, but then they got functional group apa dekat dalam alkynes?
Carbon-carbon triple bond.
Yes, carbon-carbon triple bond. Okay, good. So untuk aromatic ring, kita tahu kita ada satu jenis je lah yang kita untuk sekarang ni. Okay, iaitu arin. Okay, aromatic ni kita arin lah, contain aromatic ring. Dia tak semesti benzene ring. Nanti kita akan belajar lagi dalam chapter 6. Okay, as for aliphatic compound, that is alkanes and cycloalkanes, contohnya macam ni lah, kita ada di CH3, CH2, CH3. Dia adalah open chain structure and then this is cyclic structure. This is alkane, this is cycloalkane. So what is meant by this saturated hydrocarbon? Apa awak faham dia perkataan saturated? Apa maksud saturated? Kalau kita translate, direct translate dia, apa maksud saturated?
Tepu.
Tepu. Bila kita kata tepu sekarang, kita nak tengok tepunya hydrocarbon ni. So tepu yang dimaksudkan dalam ni adalah each of these carbon, okay, they can hold maximum number of hydrogen. So kalau kita kata tepu, bila kita kata carbon tu tepu dengan hidrogen, dia mesti ada banyak hidrogen dalam dia. So kalau aliphatic, kalau alkane dengan cycloalkane, kan dia semua single bond kan?
Yes,
Dia
Miss.
single bond,
Yeah.
jadi keliling dia ada banyak benda. So itulah dia tepu. Okay, right. So itu saturated hydrocarbon. And then for alkenes or cycloalkenes ataupun alkynes, since they got multiple bond like this, bila ada multiple bond, if we compare to alkenes just now, dia tepu ke tak tepu? Kalau ada multiple bond, dah tak tepu dah. Maksudnya bond dia
Dah
yang
tepu.
akan dikelilingi oleh other atoms dah makin berkurang. So unsaturated hydrocarbon means the molecules contain multiple bonds. Kenapa dia contain multiple bonds? Sebab dia dah kurang tepu dengan hydrogen atoms. Okay. Oh tak ada dah. Okay, itu je lah awak kena tahu sikit. Now, kenapa saya rasa sekejap. Oh memang tak ada. Okay, tak apa. Okay, at least awak dah tahu tu, okay lah. Kita kena tahu beza aliphatic, saturated, unsaturated dan juga aromatic. Itu penting. Sebab kadang-kadang dia tak bagi awak apa dia punya compound, dia bagi awak benda-benda macam tu. Kita keluarkan what kind of compound is that. Okay, now when naming a compound, we are going to use this system called IUPAC. IUPAC ni stands for International Union of Pure Applied Chemistry. Kenapa kena guna IUPAC? Boleh tak kita guna sistem lain kalau nak bagi nama compound? Boleh tak kita guna sistem orang lain? Kenapa perlu guna IUPAC nomenclature? Kenapa tak guna je panggil je lah compound, tak boleh? Boleh tak? Kenapa kita guna IUPAC?
Each compound must have an ambiguous name.
Okay, yang tu betul. Maksud saya kenapa kita nak kena guna IUPAC? For what purpose? Chemist ada kat Malaysia je ke?
Oh, international.
Yes, maksudnya kita ni banyak tau, kita ni banyak negara, banyak benua, banyak bahasa. Jadi semua orang pun saintis contohlah, dia ambil sains, dia nak jadi saintis. Macam mana kita nak unite untuk bercakap tentang benda yang sama kalau kita tak ada satu sistem yang sama? Kan? Macam nama kita lain-lain sebab sistem lain-lain contoh. Tapi apa yang menyatukan kita, maybe dari segi bahasa, is it? Same goes to IUPAC
Yes,
ni.
miss.
Awak kena tahu jugalah. Nanti orang tanya IUPAC kenapa? Tahu explain tapi tak tahu apa kegunaan dia. Sebab apa? Sebab kita ni nak bekerja dalam society, kenalah tahu, kena guna satu sistem yang sama. So for IUPAC nomenclature for alkane, specifically for alkane, so bukan alkane je, semua benda pun. So ini the very basic one. You're gonna start with the parent. So parent ni maksudnya apa? Parents ni kita boleh denote dia dalam satu structure from the longest carbon chain, okay? So we call them as parent. Okay, lepas tu bila kita ada parent, kita mesti ada family kita. So the family belongs to the suffix. So this suffix will indicate which compound do they belongs to. Kalau dia alcohol, dia ends with ol. Kalau dia alkane, dia akan ends with in. Kalau dia carboxylic acid, dia akan hujung dia acid contoh. Tu family dia lah. Parent ni is just longest carbon chain, nak tengok chain carbon tu. Okay, lepas tu kita ada anak-anak dia. Anak-anak dia kita panggil prefix yang melekat-lekat dekat parents tu. So the prefix tells you about the locations of substituents. Well, let's look at an example here. So given to you this molecule, so first you must indicate the longest carbon chain, the parent of this molecule. Could you please tell me how many carbons that makes up the longest carbon chain? Bila kata chain tak boleh putus, tak kisahlah dia sengit ke apa, jangan putus.
6, miss.
6, okay. 6 tu nak mana? Nak straight ke? Nak sengit-sengit ke? Macam mana?
Straight, miss.
Straight. Try kita buat straight. Okay. Ini sebenarnya ada beberapa possibilities lah. Okay. One of the possibilities is straight one, ataupun kalau kita kira 1, 2, 3, 4, 5, 6 pun 6 carbon juga, boleh jadi longest carbon chain. 1, 2, 3, 4, 5, 6 pun 6 carbon chain. So when determining the parent, awak kena consider all these possibilities. Okay. Alright, nanti kita akan discuss lah step by step nak ambil yang mana. Okay, ni contohnya parent. And then the suffix, can I know, do they have any functional group present in this compound? If you got only carbon and carbon single bond, ada tak any functional group present in here?
No, Miss.
Tak ada.
So, maksudnya dia tak ada family ke kalau dia tak ada functional group?
And with in. A and E.
Family in lah. Betul. Dia walaupun awak tahu dia method, prop, but, pan, hex, dia still kena ada suffix dia, family dia. Kalau dia tak ada functional group, dia still dia punya family nama dia in, hexane contoh. Okay, lepas tu yang tiba-tiba terkeluar kat tepi ni, kita panggil dia anak dia. Anak dia, dia bagi tahu tentang prefix. Okay, so we have 2 prefix in here. Okay, so jom kita tengok step by steps untuk IUPAC nomenclature. Nomenclature ni naming of compound lah. Okay, we have 4 steps altogether. The first one, you need to identify the name of parent. This can be done from the longest unbranched carbon chain. And then proceed to the numbering the parent carbon chain. Bila dah tahu parent, awak kena tentukan numbering nak start dari mana. Kanan ke, kiri ke, atas ke, bawah ke. Okay, how do we determine this? You need to look at the substituents present. Substituent ni anak-anak tadilah, benda yang melekat-lekat tadi tu. Dia cakap begin from an end that is nearer to substituents. If you have substituents, kena tengok siapa yang substituent dari arah mana yang paling dekat. Itu selalunya cara kita nak tentukanlah numbering start daripada mana. Okay, kalau you ada more substituents, okay, selain daripada tengok siapa yang kita jumpa dulu dari hujung mana, kena tengok yang ada banyak substituents. Okay, kadang-kadang kita ada longest carbon chain yang sama tapi bilangan substituents yang berbeza. Okay, prioritize the one with more substituents. Okay, next, you need to identify and number the substituents. Once you have chosen your parent carbon chain, then you need to put the numbering for the substituents. Then only you can write the name in a single word. Okay, bila kita kata single word, no spacing. Okay, but then when you have the substituent, means you need to indicate the locations of the substituent. Setiap substituents yang present kena ada location sendiri. The locations kita akan letak nombor. Okay, bila you ada number dan juga huruf, kita kena separate guna hyphen. Hyphen tu dashed. Okay, kalau awak ada number dan number, kita kena letak comma. Okay, so basically, if you have 3 substituents, you must also have 3 numbers involved. Okay, okay ke so far untuk steps ni? Sebab kita terus nak guna example.
Okay, Miss.
Okay, Miss.
Okay, so the first steps here, identify the name of parent, exactly the same as the one kita tunjuk tadi. The longest carbon chain is 6, so you might say you have this as your longest carbon chain. But then you have another representations of these 6 carbon with also 2 substituents like this. Okay, nampak sama tak? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kita ada 1, 2 substituents, 1, 2 substituents, exactly the same. And kalau kita kira number dari sini, 1, 2, ini pun 1, 2 dekat carbon number 2. Ni carbon number 3, ni pun carbon number 3. So either way akan bagi configurations yang sama with the same parent of 6 carbon chain. Okay, dua-dua pun diterima, okay? Sama je environment dia. Kalau okay, cakap okay. Saya nak proceed.
Okay, Miss.
Okay, so kita dah secure satu longest carbon chain here, but then we can also have another longest carbon chain of 6. Can you please tell me kita nak ke mana? Tadi kita dah straight, kita dah naik ke
Okay,
atas. Lagi boleh tak kita buat ke bawah ni? Dapat tak 6 juga? Kau tak 6? 1, 2, 3, 4, 5, 6? 6 kan?
Ya.
So awak kena tengok juga, jaga-jaga juga. Kalau dia masih boleh buat 6, kena consider juga. So dua-dua ni pun 6 carbon, tapi environment dia sama tak sini?
Tak.
Dia lain sikit lah, tapi kena consider sebab the first step here saya nak ajar awak tengok unbranched carbon chain dulu. So it can be either one of these. Okay,
Tapi
next
yang last
step.
tu not a chain, Miss. Dia macam attack
Mana?
together. Ada dash tu.
Mana? This one. Apa maksud dash? Ni, yang ni. Kana? Kana? Siapa-siapa? Kenapa tadi cakap apa? Tak dengar. The last one bukan branch, dash. Macam mana? Tak faham, tak faham. Hai, ya Allah.
Miss, yang like kan dia kan akan curve ke bawah kan. Yang tu.
You mean ni lah? You mean ni bukan branch lah maksudnya? Tak apa cakap je. Macam mana saya nak jawab kalau awak tak cakap?
Ni
Ha.
saya rasa maksud China tu between yang CH2, CH2 tu tak ada branch. Dia tak ada simpang tu.
Tak ada branch?
Dia kedua ke? Maksudnya dia kat sini. Between kan 1, 2, 3, 4. Lepas tu yang ni kan 5 kan sebab tak 5, 6. Tapi between ni tak ada tu.
Tak ada bond? Ni kira unbranched lah ni. Sebab dia tak putus kan? Kalau nak ikut kan? Betul tak? 1, 2, 3, 4, 5, 6.
Kiranya CH2 kira 1, CH3 kira 1 tu ni.
CH3 memang hujung. CH2. CH sama je nampak ni. CH3, CH2. Nampak tak?
Okey ni, faham?
Faham?
Miss.
Ya.
Tadi line slow, Miss.
Okay.
Yang saya cakap tu tadi.
Yang ni lah, yang ni
CH2
maksud awak.
CH2.
Dia masih CH3 kan, CH2. Lepas tu kan dia tak putus. Kan dia naik sini. Dia bersambung.
No, Miss. Maksud saya between CH2 and CH3 dia tak ada macam the dash thing kan.
Oh, tak ada masalah.
Boleh.
Ni condense.
Oh, okay.
Ni condense. Ni condensekan sekali. So dia tak ada masalah pun. Ni saya tunjuk ni macam ni. Ni saya sebab ambil exactly the same structure kat atas ni. Tapi dia orang still ada bond.
Okay, Miss. Faham.
Okay, right. So kita boleh kira ni juga sebagai unbranched carbon chain walaupun dia dah sengit, dia tak terputus, okay. So awak kena consider dua-dua ni sebab dua-dua pun a total of 6. 1, 2, 3, 4, 5, 6. Okay, tapi kita nampak dia ada environment yang berlainan. 1, 2, sini ada 1. Okay, kita go to the next steps. Number the parent carbon chain. Begin from an end that is nearer to subsequent ataupun choose the one with more substituents. Okay, so sekarang ni, kalau dalam kes ni, kita tak ada environment yang sama. So, the first ni boleh jugalah sebenarnya. Tapi dia lagi prioritize the second part. Choose the one with more substituent. Kalau awak ada lebih substituents, confirm dia menang. Walaupun dia jumpa dulu. Yang tu clear tak? Kalau you ada more substituents than the other one, is even though this substituents is located nearer to the end, kita still akan choose the one with more substituents dahulu as compared to the one that is nearer. Faham?
Faham ni.
Faham, Miss.
Okay, so antara dua ni awak rasa siapa yang kita nak pilih, atas ke bawah? Untuk kita punya parent chain kita.
Faham. Atas.
Atas. Okay, so atas, okay. Yang kat bawah ni sebab apa? Satu dia ada more substituent, dia dah menang. Satu lagi, bila letak numbering, kita jumpa number 2 dulu. Yang ni jumpa kat number 3. Okay, so yang atas lah. Okay, sebab dia ada substituents banyak. Okay, and then once kita dah tahu siapa parent chain kita dah tahu numbering. Tapi awak nak kata ini ke numbering yang the only numbering yang kita boleh buat? Boleh tak kita letak numbering kat bawah start pada sini juga? Boleh juga kan sebab 6 juga kan? Kita boleh start daripada kanan juga, betul tak? Kalau ikutkan.
Itu
1, 2, 3, 4, 5, 6. Yang ni pun another possibility. 1, 2, 3, 4, 5, 6. But then when put a numbering for substituents, Okay, you need to choose the lowest combinations of number. Okay, lowest combinations of number means bila kita ada more than one subsequence, tengok berapa banyak dia punya combination. 2 and 3 and compared to 4 and 5. Who's got the lowest combinations of numbers? Atas ke bawah?
Atas.
Yeah, yang atas. Okay, so kita akan proceed dengan yang ni lah untuk the next steps. Okay, now you need to write the name in a single word. So can you please tell me apa nama dia punya ni tadi? Parent dia kalau ada 6 carbon?
Hexane.
Hexane. Okay, so kita akan tentukan parent dia.
Hexane madam.
Okay, so at carbon number 2 and 3, we have substituents, and are they the same to one another?
No.
No. At carbon number 3, we have 2 carbon as our
miss.
alkyl group. Can I know the name of 2 carbons as alkyl group?
Betul.
Ethyl. Okay, we have ethyl starts from E. And then at carbon number 2, we have
No.
Methyl.
methyl. So methyl dengan M dengan E, siapa comes first?
E.
E.
Ya.
E. So kalau E, kita kena letak dululah 3 ethyl, barulah 2
Right.
methyl. Dia bukan ikut siapa jumpa dulu kat carbon mana. Dia kena ikut alfabet. Ni sekejap lagi baru kita akan buat. Okay. Oh, line teruk sikit Saya dengar awak lambat sikit awak punya response. Tak apa, tak apa. Okay, now. Sekarang ni kita baru tentukan who's the substituents, who's the parent. Now we're going to put them in a single word. Okay, you need to prioritize the alphabet. So you need to first letak 3 ethyl. Untuk 3 ethyl dengan 2 methyl, kita nak letak apa in between dia? Kalau huruf dengan number, kita kena letak apa? Hyphen ke comma? Number and letter. Hyphen or comma? Hyphen. So we're gonna have 3 ethyl hyphen 2 hyphen methyl. Yes. Lepas tu, lepas awak tulis substituent, jangan ada space, terus tulis hexane. Tak perlu pun nak color-color macam ni. Nanti tulis je guna pen hitam, tulis je guna pen biru. Jangan guna huruf besar juga, guna huruf kecil sahaja. Okay. Right. So we know
Okay,
already how to do the naming of this compound. Now we're going to look at the alkane as alkyl group because we know we can have branch of carbons. Maksudnya dia akan jadi alkyl group, last one hydrogen. Okay, so this alkyl group means the carbon together with hydrogen lah as a substituent. Dia akan bonded to the parent chain yang panjang tadi. Okay, we have a few types of alkyl group. The first one is unbranched. Okay, bila sebut unbranched, if you have 1 carbon, you simply have straight chain of 1 carbon. Kalau ada 2 carbon, dia terus straight chain sahaja. Kalau ada 3, prop akan jadi propyl, kurang 1 hydrogen. Sebab apa kurang? Sebab kita nak lekatkan dia dekat the parent chain. If you have butane with 4 carbon, then if they become alkyl group, they will become butyl. If you got pentane with 5 carbons, they will become pentyl. Okay, pentyl ni sambung terus lah. Ini adalah unbranched. Okay, bila dia kata dia ada unbranched alkyl group, means dia pun akan ada branch alkyl group. Okay, still branch alkyl group pun kita akan buat naming sikit sebab dia akan guna IUPAC juga. Okay, so whenever you have substituents and let's say you have only 1 substituent, macam biasa you kena first determine the parent. Can I know the parent is called apa dalam case ni? With 1, 2, 3, 4, 5, 6 carbon?
Hexane.
Hexane. Can I know the numbering starts from the right or from the left?
Right.
Right.
From the right. So,
Right.
first tentukan parent tu sekali dengan dia punya numbering. And then at carbon number 2, we have 1 substituents. What is our substituents here? With 1 on carbon
Methyl.
only?
Methyl.
Methyl. So, do you need to put a number for these substituents as the locations?
Yes.
Yeah, so you need to put 2. Is it just 2 methyl or 2 comma methyl or 2 hyphen methyl?
2 hyphen methyl.
Yes, 2 hyphen methyl. So you can simply write them in a single word called 2 methyl hexane. No spacing, please. Okay, if let's say you have 2 or more different substituents are present, so you need to write them in alphabetical order. Ni sama macam contoh kita buat tadi. Okay, we know already our parent is hexane as well. And the numbering will start from here. due to kenapa kita pilih kiri instead of start daripada kanan? Tadi dia cakap apa? Bila nak letak numbering,
Nearest substituent.
sorry?
Nearest substituent.
Yes, nearer to the end dan juga satu lagi lowest combinations of numbers possible. Okay, so we have 2 and 3. So both 2 and 3, dua-dua ada substituents yang berbeza. So kena ikut alphabet lah. Okay, kalau tulis macam ni dapatlah kita punya name 3-ethyl 2-methyl hexane. Okay, itu kalau different substituents. Okay, different substituents kena guna alphabet. What if we have substituents that are identical? So when you have 2 or more substituents that are identical, you need to use prefixes. So your prefixes will start from di. Di maksudnya dia ada 2 benda yang sama. Tri 3, tetra 4, penta 5, hexa 6, hepta 7, okta 8, nona 9, deka 10. Okay, tapi jaranglah nak ada sampai deka tu. Okay, so now you have the longest carbon chain of apa?
Hexane.
Hexane lagi starts from the left or from the right?
Left.
From the left.
From the left. Okay, good. So then you have exactly the same substituents present at carbon number 2 and 3. If you have same substituents, are you going to say 2-methyl, 3-methyl? Ke kita nak guna prefix?
No. Prefix.
Kita nak guna prefix. Okay, since, yeah, good, thank you. Since you have 2 same substituents now, by right the name is methyl only. So are you going to just take the number 2 or you need to include both number as well?
Both
Numbers.
Number, okay, please bear in mind, even though you have the same substituents, but if you have 2 of them or 3, you need to indicate all the numbers because the numbers tells you the locations of each substituents, even though they are identical. So kalau kita ada nombor dengan nombor, kita nak letak hyphen ke kita nak letak comma?
Comma.
Can you please tell me the name of these substituents present in this molecule?
2,3 dimethyl.
Yes, 2,3 hyphen dimethyl, okay? No spacing. So last kali kita masukkan nama dia in a single word, 2,3 dimethyl hexane. Okay. And then, let's say you have a number of substituents. Okay, you have a number of substituents and then they are different substituents and also identical substituents. Okay, bila nak decidekan alphabetical order? Nak decide alphabetical order, kita hanya tengok the name of that alkyl group. Contoh methyl start with M. Kita ada ethyl start with E. Butyl start with B. If you have prefixes, simply ignore the prefix. Kita tak tengok pada prefix, kita tengok pada nama alkyl group awak. Okay, untuk case ni kita ada berapa longest carbon chain dia? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 sepatutnya apa nama parent dia?
Nona.
Nona ke nonin?
Nonin.
Oh, no need.
Okay, nonin. Okay, good. Okay, so kita dah tahu nonin. Tapi sebelum kita nak tulis kat sini, saya nak tanya awak, the numbering starts from the left or from the right?
From the right.
From the right. Kenapa? Why do you think you need to start from the right? You have at 1, 2, 3, okay, third carbon. If you start from the left as well, you're going to get 1, 2, 3, start at 3 carbon as well. Kenapa awak pilih kanan instead of kiri?
Sebab
Miss
more
kiri.
number of
Sorry?
substituents.
Sebab?
More number of substituents.
More number of substituents. If you start from the right or the left, you still got 3 substituents, is it? The number of the substituents now is the same. It's just a matter of apa. If here you start from 1, 2, 3, means you got another substituents at carbon number 4, is it?
Yes.
If you start from the left, you're gonna have the second substituents located at carbon number 6. So if you have the combinations of 3 and 4, 3 and 6, who do you think got the lowest combinations of numbers?
3 and 4.
3 and 4. That's why you must prioritize the one. Maksudnya keep the second substituent lowest number. In other words, lowest combinations of number lah. So 3, 4 is much better than 3, 6, 4, 5, 6. Okay. So parent kita, nonene, and kita starts from the right. Okay, our subsequence now. We have ethyl and also methyl. Okay, ethyl and also methyl. When naming this compound, how are you going to decide whether we want to take the same subsequence first ke, kena ambil yang banyak dulu ke, macam mana? Macam mana kita nak decide? Antara dua ni, nak sebut siapa dulu? Nak bagi tahu yang banyak ke ataupun nak ambil yang ni dulu? Dan bagi tahu saya kenapa? Saya ulang soalan. Sekarang ni kita dah tahu numbering. Kita nak letak subsequence kat bawah ni. Kita ada dua jenis subsequence kan?
Ya.
Okay, kita prioritize apa? Nak tengok yang banyak carbon ke? Nak tengok yang banyak subsequence yang sama? Ke nak tengok alphabet?
Alphabet.
Alphabet. So now, this alkyl group containing 2 carbons, we're going to have ethyl, right?
Yep.
This is ethyl. This is going to be the
Dimethyl.
methyl. This is methyl. Okay, first this is methyl, but then we have prefix. If we compare E and D comes first, but are we going to take this D, this di, part of our naming of structure? Nak include dalam dia punya priority tak? Kalau ada di, D dengan E, D dulu. Dimethyl dulu. Ethyl dulu, okay? So kita akan letak 3 ethyl dulu. And then we have methyl group present at carbon number 4 and 7. Means we have, apa nak tulis kat bawah ni pula?
4,7.
Di.
Dimethyl.
Yes, 4,7 hyphen dimethyl. Okay, so last kali kita masukkan dia sekaligus. 3 ethyl hyphen 4,7 hyphen dimethyl, no name. Okay, so now let's try this structure. Look for the longest carbon chain. How many carbons that makes up the longest chain? The unbranched longest chain. 1, 2, 3, 4. Ya ke? 1, 2, 3, 4, 5, 6. Kita ada 4, kita ada 6. 1, 2, 3, 4, 5, 6, 7, 8. Kita ada 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Kita ada apa lagi? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Awak rasa yang paling panjang?
9.
9. So this is going to be our longest carbon chain. Okay, now selain dah tahu longest carbon chain of nonene 9, put the numbering. The numbering will start from the left or from the right. Kita ada berapa substituent? 1, 2, 3. Kalau dari sini pun 1, 2, 3. Dah start daripada mana numbering dia?
Tak kisah.
Tak kisah.
Mana-mana boleh.
Kenapa mana-mana boleh? Kalau start pada kiri, kita jumpa at carbon number 1, 2, 3, 4, 5. 3, 5, 7, is it?
Yes, miss.
Kalau pada kanan pun 3, 5, 7. So sama juga. So mana-mana pun boleh. Okay, and then we have different subsequence or same subsequence?
Same.
Same subsequence, we need to use the prefix of apa dalam case ni? Kalau kita ada 3?
Try.
Try. So what is the name of this compound? Can you please tell me?
3, 5, 7.
5,7.
Trimethylnonene.
Yes, thank you. 3, 5, 7. Trimethyl. No need. Okay, second structure here. What is the longest carbon chain? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the longest gonna be?
8.
8. So 8 nama dia apa?
Octane.
Octane. Okay, so kita dah ada octane now. We have exactly the same substituent, is it? Kita ada metal, ada metal, ada metal, ada metal. Sampai 4 kita ada metal. Okay, kalau kita ada 4 metal, kita nak guna prefix apa?
Tetra.
Tetra. Okay, now your numbering will start from the left or from the right?
Left.
From the left.
From the left. So the numbering will start from the left because we have the lowest combinations of number for 2, 3, and also 7. So can you please tell me what is the name of this compound?
237 tetra methyl octane.
Okay, 237. I hear only 3 numbers mentioned, but then we have 4 subsequents. Just now I said if you have 1 subsequence means they belong to 1 number. Even though they have exactly the same locations, if they have 2 subsequents, then you need to mention both the numbers twice. Jadi kat sini, instead of 237 only, supposedly they become
2337.
yeah, 2337 tetramethyl octane. Okay, good. Okay, kita dah try buat naming for alkyl group, the unbranched alkyl group. Now we're going to look at the branch alkyl group. Before you can use this branch alkyl group, you need to first know how are we going to name the branch alkyl group, because we're going to use 2 names. One is by using IUPAC, another one is by using the commercial name. Okay, commercial name maksudnya dia ada certain environment yang kita boleh guna prefix dalam nama dia tu. Okay, dia depends lah, kena tengok structure tu juga. Okay, so for branch alkyl group, the numbering, this numbering, dia numbering ni dekat atas alkyl group. Maksudnya if you have longest chain of 6, let's say, and then you have another 3 alkyl group, but they are branch, bukan unbranched. So the numbering will always starts at the point the group is attached to the parent chain. Dekat mana dia sambung, itulah carbon pertama. Bukan yang dari hujung sana, bukan dari atas sana ke apa. First carbon attached to it adalah carbon pertama. Okay. Right, so kita akan start dengan 3 carbon alkyl group. Kita tak akan start dengan 2 sebab kalau 2 dia tak boleh buat branch. 2 memang terus sambung. Kalau buat branch pun atas bawah is just a twisted versions of the original one. Okay, so the 3 carbon alkyl group, kita ada 2 alkyl group present. One is simply the propyl. Propyl is this unbranched alkyl group. Okay, from this propyl, we know the name is propyl because they got 3 carbons. So the numbering will start from here, 1, 2, and 3. So they comes from prop. Instead of propane, they become propyl. This "yl" indicates they become the alkyl group. Okay, apart from this propyl, okay, kita tahu the longest is 3 carbons. The longest is 3 carbon. Kita boleh dapat ambil satu daripada dia ni jadi branch dekat sini. So contohnya macam ni. Okay, again saya nak ulang balik. The numbering will start from the first carbon attached to the parent chain, not this one. This one. Okay, jadi the name, if according to IUPAC, the name is 1-methyl ethyl. Okay, datang mana 1-methyl ethyl? Okay, this ethyl highlighted in green belongs to the longest chain in here, which is how many carbons in here?
2 carbons.
2 carbon, they belongs to at. Okay, but then this is not ethane because they are the subsequents. So they are still ethyl, okay, ethyl. And then we put the numbering 1, 2. At carbon number 1, you have another subsequence attached to your original subsequence. Your subsequence on top of your subsequent got 1 carbon. So this 1 carbon named methyl is located at carbon number 1 of ethyl. That's why the name is 1-methyl ethyl. Okay tak?
Okay.
Okay tak okay? Okay. Yes. Apa? Okay. So ini adalah guna IUPAC. Okay. Ataupun dia tulis sini alias, the name could be isopropyl as well. Okay. Isopropyl is a commercial name. Maksudnya name yang general name lah. Okay. Where does this propyl comes from? This propyl comes from the total number of carbon you have in your alkyl group. 1, 2, and 3, is it? So that's why the name is propyl.
Yes, miss.
Okay. The name iso here, this iso means same environment in terms of apa? Dia paling hujung, dia ada same environment hold by this carbon. So this iso comes from these 2 CH3 at the end of your alkyl group. So nampak tak, dia nampak macam ekor ikan. Dia kena even tau, kena sama. Dan hanya berlaku pada CH3 je. Kalau dia ada CH2, CH3, ni pun CH2, CH3, kita tak panggil iso. Only CH3 and CH3. Dia macam ekor ikan. Okay?
Okay, Miss.
Alright. Okay, so then we have 4 carbon alkyl group. If for 3 carbon we can only form 1 branch alkyl group, is 4 carbon alkyl group we can form 3 of them. Tapi ada 4 kotak. Okay, the first kotak saya reserve untuk unbranched lah. Nak bagi tahu sikit kenapa dia unbranched. Because butyl belongs to 4 carbon, they have unbranched alkyl group 1, 2, 3, 4. Okay, so the numbering will always start from here. And then from this butyl, we may form 1 alkyl group or 1 substituents attached to the longest carbon of 3. Okay, so kalau macam ni, we have the longest chain of, kalau ikut nama, propyl. Maksudnya longest carbon chain dia ada berapa carbon?
3.
3. So the 3 tu belongs to this one. So this, the numbering starts from 1, 2 and 3. Where does this 1 methyl comes from?
The ethyl is attached to the first carbon.
Yeah, the methyl is attached to the first carbon of this propyl. So the name is 1-methyl propyl. Okay, the other name is sac-butyl. This butyl comes from the total number of carbon here. 1, 2, 3, 4 makes up the butyl. And then the carbon that holds this, the other 3 carbons, okay, they are secondary carbon. This sac comes from secondary carbon. How do we know whether this is secondary carbon or not? Look at the carbon directly attached to the parent chain. How many carbon do you have? Berapa banyak carbon yang kita ada keliling dia selain parent chain?
2.
Ada 2, sebab tu nama dia sac. Kalau 2, secondary, sac. Kalau 3, tertiary, third. Kalau 4, neo. Dia tak panggil tetra, dia panggil neo. Sec, third, neo. Okay, boleh?
Ni
Yes.
boleh ulang balik tak? Mana dapat secondary tu?
Secondary, okay, awak tengok ni. This blue line here, maksudnya dia adalah carbon yang attached to the parent chain. Tu yang membuatkan dia orang jadi alkyl group tu. So kita tengok dekat carbon ni, tengok berapa banyak carbon directly attached to it. 1, 2, is it?
Okay.
Okay, so carbon ni dia adalah secondary carbon. Kita kan dah belajar classes of carbon. Dia boleh ada sampai 4.
Ini yang
Tapi
direct,
kita tak kira lah parent chain ni. Apa dia?
direct connect dengan parent chain.
Yang direct tu. Dia memang kita tengok carbon yang direct ni.
Oh, okay.
Kalau iso tadi dia kena, kalau nak hujung tu kena CH3 je. Tapi kalau dia ada lebih macam ni, kita tak panggil iso dah. Dia panggil sac pula sebab dia dual. Dual pula. Kita panggil apa ni? Dia ada secondary lah. Ada 2 carbon groups attached to this carbon. Okay. Okay, boleh ya? Another branch alkyl group for 4 carbons adalah this one. So let's have a look. Why do we name them as 2-methyl propyl? This propyl comes from how many carbons?
3 carbons.
3. So the 3 carbons is here. So the numbering always starts from here, 1, 2, and 3. And then look at the second carbon, we have subsequence of
Methyl.
methyl. That's why the name is 2-methyl propyl. Jangan 2-methyl propane, okay? Sebab dia adalah alkyl group lagi. Sebab tu dia aryl. Okay, another name for this 2-methyl propyl adalah isobutyl. Tadi kita kata iso ni bentuk dia macam mana?
Ikan.
Ekor ikan.
Ekor ikan, bukan ikan. Ekor dia je. Ekor. Ekor dia macam ni kan? Kan sama panjang kan? Dan pendek je. Okay. Ekor ikan dia kat sini. Tu iso. Yang saya highlight in purple ni adalah iso. Okay, but then this butyl comes from
4 carbons.
4 carbons in total kan? 1, 2, 3, 4. That's why the name is isobutyl. Okay, the last branch alkyl group for 4 carbons adalah 1,1-dimethyl ethyl. So this is your parent chain. directly attached to it is this carbon. And the numbering will start from here. Maksudnya longest carbon chain here adalah 3 ke 2? Kalau dia start pada sini, 1. Boleh tak kita letak ni 1, ni 2, ni 3 sebab dia panjang?
No.
Ke kita memang kena start dengan 1 kat sini?
Satu.
Kena start dengan 1. So,
1 Miss.
1. So longest dia adalah 2. Jadi sebab tu nama dia ethyl. Okay, and then look at your first carbon here. You have 2 substituents of methyl, is it?
Yes.
You have 2
Yes.
substituents of methyl. So each of them must have their own locations even though the carbon is the same. Jadi kena letak 1,1 dimethyl ethyl. Okay. So now the other name gonna be third butyl. This third comes from tertiary carbon. So the tertiary carbon, look at the carbon directly attached to your parent chain. How many carbons attached to them? 1, 2, 3. Jadi itulah nama dia, asal usul nama dia third butyl. Kenapa butyl? Total number of carbon is 1, 2, 3, 4. Okay.
Okay.
Alright. So next, 5-carbon alkyl group. 5-carbon alkyl group, we're gonna start from the unbranched, which is pentyl. And then from this pentyl, kita boleh ada branch. So kita start dengan this one. This is the carbon directly attached to the parent chain. And then look for the longest carbon. 1, 2, 3, 4. Sebab tu nama dia butyl. Lepas tu at carbon number 3, kita ada methyl. Sebab tu nama dia 3-methyl butyl. This isopentyl, the pentyl comes from the total number of 5 carbons including the branch. This iso belongs to ekoikan. Boleh ke?
Boleh.
Boleh Miss.
Okay. Next one, we have branch alkyl group of 2,2-dimethyl propyl. So 2,2-dimethyl propyl according to IUPAC, the longest gonna be the propyl. So 1, 2, 3. Okay, at carbon number 2, we have exactly the same subsequence of methyl. Since we have 2 of them, so 2,2-dimethyl. So nama dia 2,2-dimethyl propyl. So where does this neo comes from? This neo indicates the carbon. Okay, this one, dia tak tengok yang directly attached to it. Dia nak tengok, sebab neo ni maksudnya quaternary carbon. Okay, quaternary carbon kena ada berapa carbon around dia?
4.
Ada 4. Jadi kalau kita tengok kat sini, dia 4 ke? Ni 4 tak? Tak kan? Ni 1 je, betul tak? Kalau carbon ni 1
betul.
kan? So dia ni, nama ni bukan kita sahaja buat, memang dia ada sendiri. Okay, so kita ada 1, 2, 3, 4. So the neo comes from these 4 carbons around this carbon. Neopentyl. So kalau awak tengok dia macam ni kaki dia, kaki dia macam panjang. Lepas tu dia ada 3 ni. Ni macam kaki ayam. Kan ayam kan tinggi kan? Sebab saya lupa tadi nak cakap. Kejap saya patah balik. This one, third butyl ni, nampak dia macam kaki juga kan? 1, 2, 3 kan?
Betul Miss.
Tapi dia pendek, so dia macam kaki itik. Kalau yang macam ni tadi, dia panjang sikit. Sebab apa? Dia ada extra CH2 kan kat sini.
Betul Miss.
Dia macam kaki ayam, so dia kena tunduk sikit sebab dia tinggi. Okay, so awak ingat tu je lah. Kalau kaki ayam 4, kalau kaki itik 3 sebab dia direct. So third neo, ikutlah macam nak hafal. Saya dulu hafal macam tu. Sebab dulu kan lukis skeletal kan, so ingatlah lukisan dia. Okay, last one. We have 1,1-dimethyl propyl. So this 1,1-dimethyl propyl comes from propyl, the longest carbon chain of 3 here. And then at carbon number 1 got 2 methyl, so dimethyl. So another name here is third pentyl. Third is tertiary because this carbon attached to it we have 1, 2, and 3 carbons. And then the pentyl comes from the total of 5 carbon. 1, 2, 3, 4, 5. Okay. So, awak kena tahulah macam mana nak letak nama, macam mana dari nama nak tukar jadi structure, daripada structure nak tukar jadi nama. Sebab soalan boleh bagi awak macam tu. Dia bukan chapter 5 je, dia banyak lagi chapter lain pun. Kadang-kadang dia bagi nama, awak yang kena keluarkan structure. Okay, sebab tu naming is very important. Kalau awak tak tahu nak name the structure ataupun nak keluarkan structure from the name, memang susah untuk kita buat organic chemistry. Walaupun awak hafal mechanism, awak hafal reactions, tak tahu buat structure memang masalah, okay? So tolong kuatkan your nomenclature. Kalau tak faham terus tanya saya je. Kalau buat soalan tak faham terus tanya, jangan tunggu. Okay, just now we learned about iso, contoh kita ada prefix kan, di, tetra, penta, hexa, semua tu kita kata tak masuk dalam alphabet. Tak masuk dalam naming untuk alphabetical order. Tetapi only for iso, okay, only for iso kita akan consider sebagai alphabetical order punya purpose. Jadi dia perlu masuk iso tu, kalau awak ada isobutyl, kita tak tengok dekat B, kita tengok dekat I. Tapi kalau macam secondary, tertiary, neo, kita tak masuk. Neo masuk tak? Neo macam, nanti neo tu saya double check, neo macam masuk. Okay, iso confirm lah masuk, neo tu macam masuk. Tapi secondary, tertiary tak masuk dalam kita punya alphabet. So kena tengok lah berapa carbon dia. Okay, so yes, iso masuk under I. Kalau set or third, kita kena tengok daripada punya butyl tu. Okay, now kita nak try lah satu example involving branch alkyl group. So the longest carbon chain gonna be 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So who's gonna be the parent in this case?
Heptane.
Heptane. So the numbering will start from the right or from the left?
Right.
Right.
From the right because
Lowest combination of substituents.
yes, lowest combinations of substituents lah. So kita ada heptane starts from the right. And then on carbon number 2 we have
Methyl.
methyl. On carbon number 4 we have
Isopropyl.
isopropyl. Nampaknya isopropyl. Kalau bukan nama isopropyl kita panggil dia nama apa? Macam mana kita nak nama dia? Ni parent chain tadi, tengok longest carbon chain berapa? 1, 2. Patutnya nama dia apa? 1, 2. Ada berapa dua carbon, nama apa?
Ethyl.
Ethyl. At carbon number 1 we have alkyl group attached to it lagi. Kalau satu carbon berapa apa nama dia?
Methyl.
One
Ya, 1 methyl ethyl. Okay, ataupun kita guna iso metapropyl. Okay, so kita nak letak mana? Isopropyl dulu ke nak letak methyl dulu?
Isopropyl.
isopropyl dulu.
Isopropyl. Jadi kita akan letak 4 isopropyl dan juga 2 methyl. Okay, so bila kita letak naming, macam biasalah kena prioritize the I before M. Walaupun iso is prefix tapi I is part of the alphabetical purpose punya order. Jadi dapatlah 4 hyphen isopropyl hyphen 2 hyphen methyl heptane. Okay, another example here. Look for the longest carbon chain. How many carbons that makes up the unbranched carbon chain?
8.
8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Ni pun 8. Ni pun 5, 7. 1, 2, 3, 4, 5, 6, 7. 7, 8, 9. Jadi siapa paling panjang?
9.
No name.
9. Siapa nama 9 kita?
No name.
Name. So the numbering, okay, let's say we have these as the longest chain. Okay, kita nak start pada mana? From the right or from the left? 1, 2, 3. 1, 2, 3, 4.
Right.
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 From the right. 1, 2, 4, 5, 6. Kita akan ada combinations of 3, 6. Kalau dari sini 1, 2, 3, 4, 4, 5, 6, 7. 3, 6 dengan 4, 7. Siapa lagi lowest combinations of number?
3, 6.
Kejut saya. Okay, 3, 6. Okay, so the numbering will start from the right. So kena hati-hati lah, awak kena combine juga. Marilah tahu kalau kita start pada kanan 4, 5. 4, 5. Lagi sikit pada 3, 6. By right lah. 3, 6. Jarang lah. Okay. So kita ada nonene starts from the right. At carbon number 3, we have methyl. At carbon number 6, we have methyl. So if we have same subsequence, kena guna prefix apa dalam kes ni?
Dimethyl.
Yes, kita akan guna di. So dia akan jadi dimethyl. Nak mention nombor 3 je ke? Nombor 6 je ke? Both numbers.
Both numbers.
Okay, so for this dimethyl, is di included as part of our priority untuk alphabet? No, dia akan start dengan M, the methyl. Okay, at carbon number 6 juga, we have another alkyl group attached to it. This is a branch alkyl group consists of 1, 2, 3, and 4. So kalau 4, metap prop.
Butyl.
Okay, so dia butyl. But then, this butyl now, okay, look at this carbon here. Attached to it, we have 1, 2, 3 carbons. So what kind of general name can be used for this subsequence at carbon number 6?
Third.
Third.
Butyl.
Okay, so we have third butyl. Kalau kita ikut dia punya IUPAC, kita akan tengok longest carbon chain, is it?
Yes.
Yes, kalau third butyl kita ambil T ke kita ambil B? Third tu kita ambil T ke kita ambil B?
B, miss.
B, okay, so kita akan ambil B lah. So by right kita keluarkan dulu 6 third butyl dengan 3 6 dimethyl. Tapi saya nak tanya juga, selain daripada nama third butyl, macam mana kita nak bagi nama kat sini? Kalau ikut IUPAC. This is parent chain. This gonna be the first carbon, right?
Yes.
So the longest
Yeah.
gonna be how many carbons?
2.
2. Okay, so 2 nama dia
Ethyl.
ethyl. And then at carbon number 1 you have methyl, right?
Yes, miss.
So nama dia 1, 1.
Dimethyl.
Dimethyl ethyl.
1, 1 dimethyl ethyl. Okay, kalau dimethyl ethyl kita tengok M lah. Okay, so kalau tu baik kita guna yang third butyl ni. So nanti bila awak gabungkan dalam satu single word dapat 6 hyphen third sebab dia letter dengan number, and then hyphen sebab third butyl tu bukannya satu ayat, dia third tu is the prefix je dan dia kena letak hyphen juga. Okay. Dia bukan sebab huruf dengan huruf ke huruf dengan number, sebab dia adalah tertiary singkatan. Lepas tu we have hyphen sebab kita nak letak number 3 and 6 because we have methyl located at carbon number 3 and 6. And then we have this nonene. Okay, good. Right, habis untuk nomenclature alkane. Alkane dia open chain. Okay, now kita nak tengok for cycloalkane. Cycloalkane is part of alkane but then they are cyclic structure. When naming cyclic structure, it's a bit different from open chain structure. Maksudnya yang terbuka tu. Dari segi apa? Dari segi awak nak prioritize. Kalau awak ada both carbon chain, satu cyclic compound, satu tak, and then same number of carbon. Who do you want to prioritize? Itu contoh dia. When you have subsequence, just now if you got open chain, you need to put number even if you have one subsequence. Tapi kalau cyclic structure, kena letak ke tak kalau ada satu subsequence. Tu maksudnya dah beza-beza sikit. Okay, so again sama juga dia punya syarat, dia punya basic, kita akan ada longest carbon chain tapi instead of having only the parent, kita letak depan tu nama tambah sikit cyclo. So cyclo contoh ada noun cyclohexane. Cyclohex lah basically. If your suffix in this case is alkane, means dia akan jadi cyclohexane contoh. Okay, and then the prefix sama jugalah, nak tengok subsequence apa yang attached pada the longest carbon chain. Okay, so the first syarat, if number of carbon atoms in ring is equal, okay, is equal to or greater than the number in the subsequence, dia tak cakap greater je, dia kata equal juga, the compound is named as an cycloalkane. Maksudnya parentnya adalah cycloalkane, bukan yang open chain tadi. So dalam case ni, this is your carbon chain, ini pun carbon. Ni akan jadi parent ke subsequence?
Parent.
Parent sebab dia ada longest carbon chain, is it, as compared to only one carbon here. Jadi the name gonna be
Cyclopentate.
okay,
Cyclopentate.
is the parent. Okay, and then now you have one subsequent attached to this carbon. Okay, when you have only one subsequence, do you need to put number on your ring? Macam sebelum ni
No.
tadi letak number. Okay, bila awak ada cyclic structure, if you got only one subsequence, you don't need to put any number. Okay, simply letak the name of your subsequent, which in this case the methyl, and then as the name, they're gonna be methyl cyclopentane. Itu sahaja. Itu kalau ada satu sahaja. Okay. Kita akan start letak numbering kalau ada lebih pada satu. Okay, for this one, how many carbons in your open chain here?
4.
4 carbons.
4.
What about this one?
3, miss.
3. In order for them to become parent, are you going to simply take this cyclic structure or the open chain, just because the cyclics got like macam lagi stable structure, nampak? Apa yang kita nak
The
ambil?
open chain.
The open chain. Why are you going to take this open chain instead of the cyclic structure?
Greater number of carbons.
Yes, greater number of carbon will always be the parent. So the parent will be 1, 2, 3, 4.
Butane.
Okay, so the name gonna be butane. And then why the numbering starts from here, not from here?
Starts from the one with the substituent.
Yes, sama juga macam tadi. Kita kena prioritize dekat mana substituents kita, jumpa siapa dulu. Kalau kita start pada sini, substituent kat carbon number 4 jauh. Kalau start pada sini, substituent start pada carbon number 1. Jadi the name will be 1 apa? Substituent kita ada berapa carbon?
3.
3. So nama dia
Profile.
cyclopropyl. Kena letak nombor tak? Untuk location?
Apa tu?
Yes.
Kena. Okay, kalau kita
No.
punya parent adalah open chain, kena letak nombor. Dan macam ni, kalau kita punya parent adalah carbon open chain dan dia ada satu substituent, still kena letak nombor. Berbeza pula, kalau kita punya parent adalah cyclic structure, if you got only one substituent, you don't need to put any number. Nampak?
Okay, miss. Faham, miss.
Okay, so sekarang at carbon number 1, you have cyclopropyl. So suppose the substituent is substituent
One.
awak nama apa?
Cyclopropyl.
One side.
Yes, 1. Lah, saya tak letak. Cyclopropyl, 1 cyclopropyl patutnya. Okay, 1 cyclopropyl butane lah, sebab takut nanti dia boleh juga duduk kat tengah ni kan. Dia boleh juga duduk kat tengah ni. Okay, now kita ada these 2 carbon chain. Okay, one with 3 carbon, another one pun 3 carbons. Okay, if you have the same number of carbon present in your compound, who are you going to prioritize in terms of who's going to be the parent?
The cyclic
Yeah, the
structure.
cyclic structure, sebab kalau planar structure ni, dia punya surface area lagi besar. So dia lagi stabil. So nama parent kita sekarang siapa?
Propane.
Cyclopropane. Okay, and then you have one alkyl group attached to it. So since dia hanya satu, tak letak nombor. Jadi 1, 2, 3 dia akan jadi
Propyl.
propyl. So propyl cyclopropane. Okay, awak kena tahulah beza dia. Kalau banyak sikit carbon, prioritize yang banyak carbon. Kalau sama number, prioritize yang cyclic structure as the parent. Okay, and then when the compound contains important functional group. Important functional group ni macam belajar info point tu lah. Okay, the cyclic portion is sometimes named as cycloalkyl subsequence. Maksudnya, kalau awak ada important functional group like this, carbon-carbon triple bond, And then awak ada this cyclic structure. This important functional group ni lagi lagi important lah kiranya untuk dijadikan parents sebab kita nak cari family. Kalau ni family dia alkane je. Yang ni family dia ine. Okay, so sekarang ni we have this carbon-carbon triple bond means this gonna be our parent. Okay, look at how many carbon do we have? 1, 2, 3, 4. This is 1, 2, 3, 4 juga. So they are comparable. So now this carbon-carbon triple bond is located at this end. Okay, tapi kita punya subsequence at this end. Awak nak start numbering from the left or from the right?
Left.
From the left because we have functional group present in here. Okay, walaupun sebelum ni kita cakap kena utamakan juga yang subsequence, tetapi kalau ada subsequence dengan functional group, utamakan numbering starts from the functional group. Okay, so the numbering will start from the left. Okay, so at carbon number 1 we have this alkyne. Maksudnya kena tulis ine nanti. And then at carbon number 4 we have this, what do we call this subsequence? 1, 2, 3, 4.
Cyclobutyl.
Cyclobutyl.
Okay, cyclobutyl is located at carbon number 4. What about your parent here? You have a total of 4 carbon as well. So sepatutnya kalau alkene kita sebut dia apa? Kalau alkene kita panggil butane kan?
Butene.
Butene, kalau butene adalah in double bond. Now we have 3 butane. Okay, now your butane, your carbon-carbon triple bond is located between carbon number 1 and 2. You can also do the positional isomers by relocating it at carbon number 2. So perlu tak kita letak numbering of this one before butane? Sebab dia boleh buat positional. Perlu. So parent nama dia 1 butane. Okay, 1 butane sebab this is number, this is letter, kena letak hyphen. 1 butane, the subsequence is 4 cyclobutyl. So when we combine, the name gonna be 4 hyphen cyclobutyl hyphen 1 hyphen butane. Okay, and then another syarat, cyclo is considered part of alkyl group name for alphabetizing purposes. Okay, maksudnya kita akan tengok huruf C. Bukannya kalau dia propyl, cyclopropyl, kita tak tengok P, kita tengok C. Dah sekali lah. Okay, so now your parent gonna be siapa? Kita ada sini ada 3 carbon. Oh, sini ada 3 carbon, sini ada 6. So 6 lah menang kan?
Yes, miss.
Yeah, cyclohexane. Now tell me the numbering. Okay, untuk kita buat numbering, tengok awak punya substituent. Ada berapa substituent kat sini?
3.
Ada berapa substituent? 1, 2, 3, is it?
3.
Okay, so sekarang ni macam mana kita nak letak numbering dalam cycle? Nak start pada mana? Nak ikut alfabet lagi ke? Kan nak ikut yang banyak ke? Macam mana? Awak rasa macam mana?
Yang banyak.
Okay,
Yang
kita
banyak.
akan ikut yang banyak. Okay, kita jumpa kat mana yang banyak? Maksudnya still lah lowest combinations of number. Okay, kalau awak tengok yang banyak, kita tengok kita akan ada sini kan banyak sepatutnya.
Yes, miss.
Okay, so kita boleh start buat the numbering. Maybe okay, from the left here kita pusing 1, 2, 3 sebab lowest combinations of number. Takkan nak pusing atas kan? Kita nak try to keep it low. Ataupun you can have another option 1, 2, 3. So you want to go with the red or with the green one?
Green.
The green one. Okay, now your green suggests at carbon number 1 you have 2 methyl groups. At carbon number 3 you have cyclopropyl. Okay, how are you going to name the substituent? Siapa yang kita nak prioritize? Dari segi nak letak yang siapa dulu? Dimethyl or cyclopropyl? Cyclopropyl. Even though the number is 3, not 1, but then when naming, you need to prioritize the alphabet. Okay, cyclo C comes before methyl. Okay, jadi kita letak 3 cyclopropyl And then 1,1-dimethyl. So in a single word, we have 3 hyphen cyclopropyl hyphen 1, 1 hyphen dimethyl cyclohexane. Okay, then okay, ni kalau melibatkan substituents if only one substituents present, no number needed. So methyl cyclopentane only. If you got 2 same substituents, number the ring so that the second substituent has a low number as possible. In other words, lowest combinations of number. Okay, contohnya kita ada this, what do we call this parent?
Cyclohexane.
Cyclohexane with 2 alkyl group attached to it, which is methyl. So the numbering, kita akan start mana-mana pun boleh. 1, 2, 3 pun sama. 1, 2, 3 pun sama. So the name gonna be, bagi saya complete name dia. Full name dia apa?
1,3-dimethyl cyclohexane.
Yes, 1,3-dimethyl cyclohexane. Okay. Next.
1,3-dimethyl.
Yes, cyclohexane. Okay, then we have 2 different substituents. Okay, now we have 1 methyl dan juga satu lagi ethyl. Okay, tapi saya tak letak nombor lagi lah. Dia sudah ikut alfabet. So kalau ikutkan alfabet, sepatutnya siapa dulu? Ethyl ke methyl?
Ethyl.
Ethyl. So we have a number of combinations here. Jadi kita nak ambil yang ethyl lah dulu. So ambil yang hijau ni. So we have this. Apa nama dia nanti? Kalau kita ambil yang green?
1 ethyl, 3 methyl, cyclohexane.
Yes, 1 ethyl, 3 methyl. Okay, ni tak ada sorry, nanti saya padam. Ni tak ada hyphen, dia terus sambung. Alright, and then when 3 and more substituents are present, okay, begin the numbering at the substituent that gives the lowest set of locations number. Okay, ni lagi satu masalah. Kalau dia ada lebih daripada 3 kan, awak janganlah tengok sebab dia ni alfabet paling kecil ke tak. Kita kena tengok hujung ke hujung. Walaupun contoh contoh kat sini ethyl. So yang ni methyl, ni ethyl. So awak pun macam kena utamakan alfabet ni, tak. Awak tengok je siapa yang akan menutup siapa. So kalau kes ni 1, 2, 3 contoh. 1, 2, 3. Kita kena ambil this end to this end. Jangan tiba-tiba ni nombor sebab dia alfabet dulu ambil dia. Padahal tak ikut turutan. Okay, so sekarang we have ethyl group present and also methyl group. Okay, and then you kena letakkan lowest set of locations number. If you start from here, awak akan dapat, sekejap, kita ada combinations. Saya suggest kat awak. If you start from here, you're gonna have 1, 3 and 4, is it? So
Yes,
1,
miss.
3 and 4. And then kalau kita start daripada yang hijau, 1, 2 and 4. So between 1 to 4 dengan 1 to 4, siapa lagi kecil dia punya combinations of number?
1,
1
2,
to 4.
4.
Yes, 1, 2 and 4. Jadi kalau kita name dia, dia akan jadi macam mana nama dia ni? Naming still guna alfabet.
1, 2, dimethyl, 4, ethyl, cyclohexane, sorry.
Okay, just now you start with 1. Your 1, awak tengok dekat di ke awak tengok kat methyl? Dia punya huruf. The alphabet starts from di or M, D or M for methyl.
D.
Di is the prefix that is not included as part of the alphabetical order. Di, tetra, third, sec tak masuk. Yang masuk hanyalah iso, pergi cyclo kan. So di tak masuk
Okay.
di tak masuk. Bila di tak masuk kita tengok M. Kalau ethyl kita ada E. E dengan M siapa dulu?
E.
E dulu.
E. So nama dia 4 ethyl, 1, 2 dimethyl. Ni pun tak ada. Silap. Cyclohexane. Tak ada dash ni. Nanti saya edit baru saya upload the notes. Okay. Okay, habis untuk naming. Okay tak naming dia? Agak-agak boleh buat tak? Sebab kita punya tutorial banyak juga tu naming. Next hour saya nak bincang tutorial tau. Okay, naming?
Okay.
Okay, miss.
So now kita nak masuk physical properties. Okay. Physical properties ni benda yang kita boleh ukur dia. Selalunya kalau dalam lab lah. Dalam lab contoh awak nak tahu strength of their intermolecular forces. Kita tengok boiling point. Kita nak tengok hydrogen bond dia, nak tengok dia punya ability to dissolve or not, kita tengok solubility. Okay, that's what we call physical properties. Okay, as for alkane, we have this boiling point contributed by these three factors. One is the molecular weight. What is meant by this molecular weight? When they we only talk about different molecular weight ke kita nak compare in terms of molecular weight when they got different number of carbons. Kalau dia cakap dia bagi awak same number of carbon but only branching or straight chain, yang tu tak masuk case molecular weight, dia dah masuk case isomeric alkane. Dalam alkane kita hanya ada chain isomers, so kita kalau comparable size kita tak cakap pasal molecular weight, kita cakap pasal surface area, datang pada branching or straight chain. Okay, other than that is between the open chain dan juga cyclic structure. So boiling point kita nak tengok 3 case ni lah. Macam mana kita nak tahu dia punya molecular weight tinggi, besar, dia punya boiling point tinggi. Kenapa? Kalau dia ada comparable size, kenapa kita kata yang straight chain lagi tinggi boiling point daripada branched. Lepas tu kalau kita ada alkane dengan cycloalkane, kenapa kita kata cycloalkane lagi high boiling point than the alkane? Benda ni lah kita nak discuss untuk trend of your physical properties. Okay, in terms of solubility, we're going to look at only 2 solvent. One is water. Water adalah polar solvent. Sama ada dia boleh dissolve in water, boleh buat hydrogen bond or not. So recall balik the criteria to form hydrogen bond. Okay, and then organic solvent is basically containing carbon and hydrogen, means they are non-polar solvent. Okay, maksudnya kalau dia tak ada, dia dissolve, dia ada carbon and hydrogen, dia ada carbon hydrogen, boleh ada dissolve, tu maksud dia. Okay, we'll start from the boiling point in terms of molecular weight. Okay, bila sebut molecular weight kena berbeza size. Bila berbeza size bukan dari segi bentuk, berbeza size dari segi molecular mass. Molecular mass kita tahu kalau satu carbon 12 gram per mole. Kalau awak ada 5 carbon 60 gram per mole contoh. So itulah membezakan dia. So if you are given compound with 5 carbon, 4 carbon and 3 carbon, then you can explain the boiling point in terms of their molecular weight. Okay. So the explanations must consist of all these things. When you have bigger molecular size, you're going to have larger surface area. Kan? Logiknya lah, bila something tu besar, surface area lagi besar. Ni saya pernah cerita dah dari segi itu branching, sorry. Kiranya surface area dia untuk dia buat reactions. Okay, when you have larger surface area means the reactions taking place adalah the van der Waals forces. Kenapa kita kata van der Waals forces? Because we are now talking only about the alkane. Okay, the alkane got only carbon and hydrogen. Maksudnya dia hanya boleh buat van der Waals forces yang paling lemah. Siapa van der Waals forces yang paling lemah? Kita ada 2 jenis dulu. Van der Waals forces paling lemah kita panggil dia apa?
London force.
Yes, London forces. So bila larger surface area, banyaklah van der Waals forces kita boleh buat. Bukan kita lah, molekul tu boleh buat. Bila banyak, walaupun dia lemah, sama dia akan jadi strong. Bila strong, senang tak nak break the forces between the molecules. Bila van der Waals forces dia kuat. No, maksudnya macam mana kita nak tahu susah ke tak, dia bagi daripada bacaan boiling point awak lah. So more energy needed to overcome the forces means the higher boiling point for that particular molecule. Okay, so if we look at the example given here, you have butane, you have pentane, you have hexane. So you know they each of them got different number of carbons, right?
Yes, miss.
Okay, bila dia bagi different number of carbon, boleh tak kita cakap pasal molecular weight?
Boleh.
Bila explaining about a trend, you must emphasize their difference instead of their similarities. Okay, so butane has lower boiling point than pentane, pentane has lower boiling point than hexane. Okay, kenapa? Okay, kalau kita tengok kat sini, sebab awak boleh cerita lah, awak kata hexane has the biggest molecular size. So bila dia ada biggest molecular size, what will happen to the surface area?
Larger.
Increase.
Larger. Bila larger means van der Waals forces form is greater or less?
Greater.
Bila greater, maksudnya more energy needed to overcome the forces between them, is it?
Yes.
Yes.
Hence, boiling point is high. Okay, bila explain tentang trend, saya tak bagi contoh dan lain lah. Okay, bila explain tentang trend, tak boleh cerita dia seorang sahaja. Kena cerita apa lagi antara diorang dua. Awak boleh cakap pula, butane has lower boiling point than pentane because it has smaller surface area due to smaller molecular weight. Macam tu je, asalkan awak mention tentang dia. Okay. Kalau dia benda yang sama, mention sekali je lah. Yang benda fullnya kita pernah buat kan sebelum ni. Okay, right. Next factor adalah effect of branching. Okay, branching kita dah belajar chain isomers untuk alkane. Okay, so basically branching of your carbon chain will reduce the surface area. Okay, bila dia reduce the surface area, less reactions will take place. Less reactions here means the formations of your van der Waals forces between the molecules pun akan jadi berkurang. Sebab dia tak banyak ruang untuk dia pergi react. Okay, bila weaker van der Waals forces, kita tahu tak boiling point dia tinggi ke rendah?
Rendah.
Rendah sebab
Rendah.
senang je kita nak penetrate. Jadi less energy needed, therefore boiling point low. Okay, so now I'll give you an example of this pentane containing 5 carbon. Okay, tengok bawah ni. 2-methyl butane pun 5 carbons, 2,2-dimethyl propane pun 5 carbons. So when you have comparable size, bila sebut comparable size adalah dia punya isomer lah. Sama carbon dia, sama dia punya molecular structure, dia punya molecular formula. Yang berbeza adalah dia punya dia punya chain isomers. Okay, so sekarang ni kalau kita tengok the boiling point, kenapa boiling point yang 2,2-dimethyl propane ni paling rendah? Kalau kita compare dengan pentane paling tinggi. Okay. So kita akan cerita tentang effect of branching. Okay. So from here we know pentane has the highest boiling point, followed by 2-methyl butane, followed by 2,2-dimethyl propane. Okay, how are we going to start to explain about this? Macam saya ajar tadi, kita pilih satu yang paling tinggi ke paling rendah ke. Let's say kita nak cerita paling tinggi. Kita pilih paling tinggi sebab dia paling berbeza kan, antara lagi dua kan.
Yes, ma'am.
Diorang ada branching, dia tak ada. So, prioritize apa yang diorang berbeza. So, macam ni kita nak start. Pentane. Macam nak start? Pentane.
Unbranch.
Jangan
Has
tu,
like-
sekali tu bagi jenuh. Boiling point dia tadi. Pentane has the,
Highest boiling point. Then
because bila highest tak payah then lah. Highest cerita pasal dia dulu. Pentane has the highest boiling point sebab apa? Ni straight chain ke branch?
straight chain.
Bagi tahulah. Pentane has the highest boiling point because it got straight chain. Bila straight chain, surface area dia besar ke kecil?
Besar.
Bila surface area besar, van der Waals form banyak ke sikit?
Banyak.
Banyak. Bila
Banyak.
van der Waals forces formed banyak, strength dia kuat ke lemah?
Kuat.
Kuat. Susah tak nak break the forces between them?
Susah.
Susah.
So that's how you explain about this pentane only. Boiling point of pentane is the highest due to straight chain, has the largest surface area. Kena cakap juga bila highest tu, just mention lah antara diorang dua ni. Tak mention pun tak apa lagi kat sini. Sebab nanti kita nak sambung lagi pasal dia. So cerita siap-siap, van der Waals forces can be formed is greater, van der Waals forces pun makin kuat. Okay, then we need to also emphasize about these two. These two got similarities in terms of branching, but what's the difference between these two apart from their boiling point? Apa awak nampak? Branching dia berapa banyak sini? Sini berapa banyak? Nak cerita macam mana ni?
More branching, miss.
Okay, these 2,2-dimethyl propane supposed to have lower or higher boiling point?
Lower.
Lower. So 2,2-dimethyl propane, dia ada banyak lagi
Lower.
branch. Yes, daripada 2-methyl-butane. Okay, jadi awal je nak start dengan boiling point low, tapi ni saya bagi tahu branch dulu. So bila branch banyak, surface area dia pun makin kecil, is it? Surface
Yes, miss.
area is smaller. So bila dia smaller, dia lagi compact, lagi susah dia nak buat reactions. Therefore, boiling point of 2,2-dimethyl propane is lower than that of 2-methyl-butane. Awak tak perlu nak ulang benda ni banyak kali. Enough cerita sekali, bawah ni just emphasize the difference saja. Okay.
Okay, miss.
Alright. Okay, last one for boiling point. We gonna look at the boiling point of alkanes and also cycloalkanes. Okay. Cycloalkanes is said to have higher boiling point than the alkane. Kenapa? Bila sebut boiling point, kita memang nak emphasize surface area. Kenapa awak rasa cycloalkane punya boiling point lagi tinggi?
Has
punya
a larger
cyclic structure.
surface area.
Yes, surface area untuk cycloalkane lebih besar. Kenapa? Dia kan duduk atas plane kan?
Betul, miss.
Bila dia duduk atas plane, dia take up all the surface area yang atas plane tu. So dia jadi besar lah. Kalau alkane yang straight chain tu je, dia ambil part tu je, ada part yang dia tak kena. Sebab itulah cycloalkane ni dia adalah planar structure. So planar structure, surface area dia lagi besar. Bila surface area besar, automatic semua explanation lepas tu semua sama dengan yang tadi. Cakap pasal van der Waals forces banyak, kuat, boiling point tinggi. Okay. Next one for physical properties, we have solubility. It's quite straightforward. They are insoluble in water. Kenapa they are insoluble in water? Cuba tengok structure alkane. Ada tak any criteria yang obey untuk dia form hydrogen bond? Ingat lagi tak criteria required for hydrogen bond to occur?
Handphone.
Kena ada handphone. So at least the molecule contohlah daripada water kan, sebab dia kata water kat sini, water kita tahu memang ada OH lone pair, is it? Okay, so adalah at least ada handphone. H directly attached to either F, O ataupun N. But then, bila dia kata insoluble in water means the alkane itself CH3, CH3. The neighboring molecule which is the alkane should have lone pair on them. Dia ada tak lone pair atas CH3, CH3? Dia ada tak lone pair dekat CH3, CH3?
Tak.
Tak ada.
Bila dia tak ada lone pair, dia tak obey the second requirement. Maksudnya sebab tu dia tak boleh dissolve in water. In other words, they are insoluble in water because they cannot form hydrogen bond. Okay. If they are dissolved in organic solvent, okay, your organic solvent, let's say you have this CH3, CH3, and then you have organic solvent of benzene. Okay, this benzene, they contain only carbon and hydrogen. Allah. Dia ada carbon and hydrogen, means kat sini ada hydrogen. So hydrogen dengan carbon, kalau diorang macam duduk dekat, diorang akan form this London forces, is it?
Yes, miss.
Ya.
London forces, bila dia boleh buat London forces, maksudnya dia try to react lah. Bila dia try to react, maksudnya dia can dissolve lah in organic solvent. Sebab tu dia cakap, alkane is insoluble in water sebab tak boleh buat hydrogen bond. Tapi alkane is soluble in organic solvent sebab at least dia boleh form the London forces. Okay.
Okay, miss.
Okay.
Okay, sikit lagi dah masuk reaction ni, sikit lagi. So reactions of alkane, bila sebut alkane dia ada beberapa reaction, sikit je. Reactions of alkane hanya ada dua. The first one is combustion. Okay, combustions kita tahu reactions with oxygen gas, but then we have two types of combustions. One is complete combustions and the second one is incomplete combustions. So what's the difference between these complete combustions and incomplete combustions? Complete combustions will form CO2 and water with in the presence of excess O2. Okay, some might ask, how do we know whether the reactions got excess or limited O2? If they didn't say anything, assume they are in excess oxygen. But if they mention the reactions takes place in limited oxygen, itu adalah incomplete. Kita bukan tengok dia complete combustion ke tak, excess ke less O2 tu daripada this stoichiometry, this number 2 here ke, this setengah ke, kita tak tengok sini. Kalau dia cakap incomplete, dia akan bagi tahu. Dia not incomplete, dia bagi tahu. Okay? Kalau dia tak cakap apa-apa, memang dia complete combustions. So bezanya nak tahu, tengok produk je lah caranya. Kalau CO2 and water, dia adalah complete combustions. Kalau dia dapat CO dan water, dia adalah incomplete combustion sebab limited O2, sikit je oksigen dia. CO ni lah nanti kalau contoh bakar, dia nampak macam suit tu. Suit tu yang jelaga hitam-hitam tu, kiranya combustions dia tak lengkap. Okay, tapi kita tak tengok this coefficient 3/2 ke tu, kita tak tengok sini. Dia akan bagi tahu kalau dia kata incomplete. Okay. Right. The second one is halogenations. Okay. These halogenations, can I know they are the name of reactions or type of reactions? Halogenations. Name of reactions or type of reactions?
Name of reaction.
Name of reaction.
Name of reactions. Okay. Type of reactions, ingat hanya ada substitutions, addition, elimination dan juga rearrangement. Kalau nama macam halogenations, hydrogenation, benda-benda macam tu, itu adalah nama. So hati-hati bila soalan minta name or type. Usually dia akan tanya type. Okay, these halogenations ni awak akan jumpa banyak tau. Dalam haloalkane pun jumpa, dalam alkene pun jumpa, banyak lah. Okay, jadi this Asian here not necessarily addition, not necessarily eliminations, not necessarily substitutions. It all depends on your initial structure to start with. Let's say kita ada alkane kan. Alkane semuanya single bond. Okay, bila alkane semuanya single bond, dia capable untuk buat reaction apa? Kalau type of reaction, daripada 4 tu, kan kalau kita asalnya ada single bond, awak rasa dia boleh buat reaction jenis apa? Daripada 4 tu.
Substitution.
Substitutions pun boleh, okay. Lagi? Addition
Free
boleh tak?
radical substitution.
Addition boleh tak agak-agak? Kalau ada single bond, kalau kita nak add lagi, boleh ke?
Tak boleh.
Boleh, dah cukup dah. Add addition tak boleh. Boleh tak kita buat eliminations daripada single bond?
Boleh.
Boleh, okay. Tetapi kita nak tengok, halogenations here means kita tak, bila sebut halogen, dia akan melibatkan halogen from group 17. Okay. If you start with on the alkane containing carbon and hydrogen, so kita dah narrow down tadi, selections kita either substitution or elimination. Kalau asalnya awak ada C dengan H, bolehkah awak buang halogen daripada alkane awak? Ada ke halogen asalnya?
Tak ada.
Tak ada. Jadi eliminations dah disqualified. Tinggallah substitution sahaja. Okay, so kalau kita tengok this structure, maksudnya alkane, halogenation dalam alkane hanyalah substitutions. Substitution jenis apa? Kita ada 3 jenis. Okay, adakah electrophilic aromatic substitution? Adakah dia free radical substitutions? Adakah dia nucleophilic substitutions? All these reactions, it all depends on your initial structure to start with. Okay, now we have alkane, right? We have only carbon and hydrogen bond. Carbon and hydrogen bond, can I know they are polar or non-polar bond? Carbon-hydrogen bond is polar or non-polar bond? Carbon-hydrogen bond, they are polar or non-polar bond?
Non-polar.
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 Bila non-polar, kita akan melibatkan cleavage jenis apa? Homolytic or heterolytic?
Homolytic.
Homolytic will create what kinds of intermediates? Homolytic will create what kinds of intermediates? We have 3 types of intermediates. Kita jumpa.
Free
Homolytic,
radicals.
Yeah,
Free
free
radical.
radical. So you know already if you have alkane, the only possible reactions taking place adalah free radical substitution. Sebab somehow reaction akan berlaku by breaking and forming a bond. Okay, dapat je alkane, terus tahu free radical substitution. Don't bother with anything else dah. Alkane terus free radical substitution. Okay, so the halogenations take place when you have your alkane and then to react with this Cl2. This Cl comes from the halogen group, group 17. Because they involve the cleavage of non-polar bond, they will require light or UV or HV untuk help the reactions, to aid the reactions so that they can do the substitutions. Okay, the substitutions takes place is mono-substitution. Maksud mono-substitution, bila dia buat reactions, sekali dia buat, dia replace satu saja. Kalau dia nak replace satu lagi, dia kena undergo reactions lagi. Sebab tu dia boleh juga substitute sampai 2. Lepas tu kalau nak buat lagi kali ketiga. Substitute lagi. Okay. So, bila dia boleh substitute sampai habis ni, maksudnya dia punya persen pun yang paling banyak mestilah yang awal-awal. Dah habis, dah ditukar semua, dia try tukar bagi masuk 2 pula. Sebab tu makin sikit dia punya percentage. Okay. Okay, maksudnya setiap kali kita buat ni, dia akan replace satu sahaja, bukannya terus replace banyak-banyak. Walaupun ditulis sini Cl2, sebenarnya they got abundance of Cl2 in their reactions. But then, once reactions happen on this substitute one, sebab tu mono substitution, dia tak ubah semua. Dia melibatkan satu bond sahaja at a time. Okay, so in here, you have only one type of hydrogen. Kenapa dia cakap one type of hydrogen? If we further expand this structure, you can see you have only C, H, 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 and H, is it? Kan?
Okay.
Okay, when determining the class of hydrogen, kita akan bear this carbon bearing the hydrogen. So you got no carbon directly attached to it. Maksudnya kita ada satu jenis je hydrogen which is primary. Jadi dia akan tukar-tukar still primary lah. Okay, if you have an alkane with more than one type of hydrogens, maksudnya you can have secondary and tertiary as well, awak akan dapat a mixture of product like this. Okay, so let's say you start from propane, you could see these hydrogens belongs to what class of hydrogen? Primary, secondary or tertiary kalau carbon ni? Hydrogen attached to this carbon, what is the class of hydrogen?
Tertiary.
This carbon bearing the hydrogen directly attached to it, how many carbons? Ni saya lukis balik this CH3 yang saya lukis besar ni kan, directly attached to it is C, right?
Tak.
Betul tak?
Okay.
Yes. Now,
Betul.
yeah. Yang tadi bukan primary tau, silap, yang tadi adalah methyl. Okay, so sekarang ni, your propane yang saya lukis tu, berapa banyak carbon directly attached to the carbon bearing the hydrogen?
One.
One.
Jadi dia belongs to class of hydrogen apa?
Primary.
Primary. Okay.
Primary.
Yeah. Do you have hydrogen attached to this carbon?
Yes.
Can I know the class of hydrogen for this class of hydrogen untuk yang ni?
Secondary.
Secondary. So, bila awak ada lebih pada satu jenis hydrogen, dia boleh form a mixture of product like this. Faham?
Okay.
Bila dia ada mixture ni, yang nak masuk mekanisme ni adalah yang paling stabil. Mana kita nak tahu paling stabil? Kita bila melibatkan alkane, kita akan form intermediate apa awak cakap tadi? Kalau non-polar bond kita pecahkan dia, kita dapat intermediate species apa?
Free radicals.
Free radical. So, in order for you to know who's
Free
going
radical.
in your mechanism, produk apa yang kita nak dapatkan dari mechanism, kena check the stability of your intermediate species. Okay, so this mixture of product lah boleh dapat dari sini sebab dia tukar one at a time. Okay, now we're going to look at the stability of free radical juga. So at the moment, kita tadi kan tengok classes of hydrogen, right? We have these classes of hydrogen, yang ni kita panggil dia methyl. Yang ni sebab attached to one alkyl group, kita panggil dia primary. This is secondary because we got two alkyl group. This one is tertiary. Okay, so now we learn that for free radical species, okay, recall balik, for free radical species, they are electron deficient or electron rich species.
Electron deficient.
Okay, electron deficient maksudnya dia banyak elektron ke kurang elektron?
Kurang
Kurang.
elektron.
Dia kurang elektron, macam mana kita nak stabilkan dia? Kita kena ada bagi banyak elektron ke kita kena kurangkan elektron keliling dia nak stabil?
Banyak.
Tambah elektron.
Kena banyakkan. So kita nak banyakkan, kita kena letak electron donating group kan?
Yes, miss.
Yeah.
Your electron donating group gonna be the R, right? The alkyl group, is it?
Yes.
Okay, we know by having more alkyl group directly attached to your your free radical species in alkane, dia akan stabilize or destabilize?
Stabilize.
Dia akan stabilize. But now, in order for you to do the apa kita panggil tu? Bila dia stabilize, maksudnya dia akan kuat kan? Tapi bila dia kuat, dia akan melemahkan the carbon hydrogen bond ni. Bila dia ni kuat kan? Senang tak dia nak lepaskan yang hydrogen tu?
Senang.
Senang je. As compared to this one, yang kat hujung ni, dia tak ada alkyl group attached to it. Jadi, dia macam susah sikit nak lepaskan. So, kita dah boleh tahu, when you have stable free radical, maksudnya, lagi senang lah untuk kita remove the hydrogen, is it?
Yes.
Yes, so kita boleh tahu juga kalau dari segi hydrogen the bond strength untuk CH, kalau lagi ke kiri lagi kuat, kalau lagi ke kanan lagi lemah. Okay, bila lagi lemah, weaker CH bond, lagi senang tak untuk kita remove dia?
Senang.
Lagi senang. So bila lagi senang sekarang ni, kenapa kita kena tahu benda-benda ni? Sebab kalau awak ada different classes of hydrogen present in your compound, the one to be included in the mechanism is the one that is easier to be removed. Maksudnya kita akan pilih yang stabil, yang dia punya tertiary free radical. Kita akan pilih, dia akan substitute kat situ instead of the substitute dekat primary. Itu contoh dia lah, sebab tu kena tahu stability ni. Okay, so bila stable radical form leads to formations of major product. Okay, awak nanti bila kita cakap stability, you tend to have mixture of product. So from the mixture of product, you need to identify who's going to be the major, who's going to be the minor product. Major product yang terhasil daripada stable intermediate species yang senang kita nak remove. Minor product yang barangkali kita akan dapat, dia akan terhasil daripada compound yang kurang stabil dari asalnya sebab dia susah nak lepaskan the hydrogen. Okay. So yang tu clear So saya teruslah daripada reactions tu kita akan tengok sikit the mechanism. Okay, when we say mechanism, we're talking about the movement of electrons. How from the reactants, they undergo reactions to form that kind of product at specific place. Okay, jadi macam nak dapatkan tempat tu, kena undergo a reactions. Undergo a reactions now, not just the arrow, the straight arrow like that, kita akan guna curly arrow. Okay, the one that we have learned a bit lah dalam 4.4. Okay, in free radical substitutions, Allah 2 kali substitution saya. That takes place only in alkane. Okay, please remember free radical substitution dalam alkane sahaja. Dan this is the first mechanism you are going to learn for this semester. Okay, you are going to involve these 3 steps. The first one is initiations. Initiations is where you initiate the radical to be formed. Okay, jadi dekat step ionizations ni kita akan form the radical. Radical adalah awak ada unpaired electron. Okay, and then once you have formed this free radical, they will become highly reactive. Dia tak akan duduk saja, dia sangat reaktif. Kiranya awak introduce dia to some other reagent, dia terus je attack. Bukanlah attack, dia terus buat reactions. As for the second step, we have propagations. So during propagations, the free radical formed during the first step ionizations will create a new radical. So then the new radical form takkan stay still, dia akan attack balik the halogen yang kita buat dekat dalam ionizations dari step tadi tu untuk dapatkan radical yang sama seperti step 1. And as the last steps, terminations. This termination sebab kita nak hasilkan stable compound, jadi no more new radicals akan formed. Apa yang kita akan buat dekat sini? Two radicals will combine. Radicals yang kita dapat during the first steps, dia akan combine together between the same species and also different species. And by doing this, the chain reactions will stop. Takkan lagi ada radicals yang form dan reactions akan jadi stabil. So, the reactions takes place between alkane and also your halogen. That's why the name is halogenations with the presence of light or UV or HV. Either or, depends on the questions. Kalau question tak bagi, letaklah any of them. Asalkan kena ada UV, HV ataupun any source of light. Okay. Look at this carbon, this alkane, okay. Tadi kita cakap bila awak ada alkane dan awak ada different classes of hydrogen, so they tend to have a mixture of product, is it?
Yes, miss.
Yes. Can you please tell me how many class of hydrogen present in this compound? Ada tak primary? Ada tak?
Ada, miss.
Ni apa? Kalau carbon ni apa?
Primary.
Primary. Kalau carbon, kalau hydrogen ni?
Secondary.
Secondary. Kalau hydrogen ni?
Tertiary.
Ni pun sama tadi, secondary, primary, secondary, primary. So basically we have tertiary, secondary and primary hydrogen, is it?
Yes, miss.
Okay, bila awak ada classes of hydrogens present, means you akan dapat a mixture of product. Okay, apa yang kita nak buat sekarang, kita nak gantikan hydrogen attached to this carbon with one of the Br, only one, because this is mono substitutions. And on top of that, Br2 is very selective instead of Cl. Kalau Cl, dia ada possibility untuk masuk juga yang lain. Tapi kalau Br, dia memang akan prioritize major product, the one that is very stable. Okay, the one that is very stable dekat ni lah, dekat tertiary ni, tertiary hydrogen. Okay, so bila kita substitute, undergo free radical substitutions, kita akan dapat the first product here, and then the second product here, and also the third product here. Okay, between these three, the red one gonna be the major product, while the green and blue one will become the minor product. Br2 is very selective, usually dia akan form this major product. Okay, so untuk mechanism, kita akan fokuskan pada major product. Maksudnya, the movement of electrons will focus only on the formations of major product. Walaupun awak akan dapat minor product lain, kita hanya akan tunjuk satu sahaja yang menjadi major product. Make sure dapat dekat dia ni, macam tu. Okay, so we're going to start with the first steps. During the first steps, you will take the halogen, okay, and then with the presence of this UV light, you will undergo this homolytic cleavage. Bukan you, the molecule will undergo homolytic cleavage, starts from the bond. They will break symmetrically, got equal number of electrons, one unpaired electron each. Okay, kena ada this presence of light, then only you can get your free radical species. Okay, up until now okay ke? Boleh ikut ke steps ni?
Boleh, miss.
Okay. And then the second steps, we have propagations. These propagations means you are going to form new radical. You initially have this Br radical, and then this Br radical cannot still. Dia akan keep on buat reactions. So dia nak buat reactions kat mana? Sebab dia free radical, kalau dia nak buat reactions, dia pun kena pair up dengan free radical. at the moment, do you have any free radical present in this molecule?
No, miss.
Tak ada. Jadi macam mana kita nak adakan the free radical?
Eliminate the hydrogen.
Eliminate the hydrogen. Basically kita nak cleave this bond between carbon and hydrogen, right?
Yes, miss.
Okay, so now kita akan cleave this bond. Okay, this bond is cleaved. But then this hydrogen, the electron goes to hydrogen will be taken by this Br radical. Sebab once dia pecah, dia tak akan duduk diam. Dia akan pair up dengan orang lain. So by right dekat sini kita akan dapat new radical of this carbon radical awak, dan juga kita akan form a new species here, HBr. Okay, and then kita tak habis sampai sini sebab kita form new radical kan. New radical ni sangat reaktif. Jadi kita akan ambil balik kita punya free radical here. Kita ada banyak sangat Br2 dekat dalam kita punya reactions. Dia akan buat lagi ulang dan ulang dan ulang. Kalau ni free radical, dia akan pair up dengan Br pula. And then this Br kita akan undergo homolytic cleavage like this. Make sure when you transfer the electron, they meet one another. Kena dekat. Tak adalah kena rapat sangat, tapi kena dekat menunjukkan yang dia berjumpa untuk buat bond. Bukannya seorang jauh sana, seorang bawah sini. No, kena dekat sebab kita nak transfer the electron. Okay, and then this Br will again form from the radical yang kita dah create during the first steps. So awak nampak tak dekat sini you form a new radical and then awak akan keep on forming the same radical again and again. Maksudnya chain reactions akan tetap berlaku lah dekat steps ni. So that's why kita tak boleh teruskan bagi dia berlaku sampai bila-bila, tak boleh. So kita kena terminate dia. So that when you have these termination steps. Okay, during these termination steps, you're going to combine the two radicals together. It can be between the same radicals dan juga different radicals. Asalkan dia radicals, dia akan pair up. So this Br pair up with this Br radical, dapatlah Br2 again. Once dia dah form these stable molecules, maksudnya dia dah zero charge balik, maksudnya dia dah stabil. Bila dah stabil, dia bolehlah reactions tu boleh stop. Kalau yang ni pula, these two radical will combine to form a bond between them like this. Jadi bila dia dah stable, dia akan stop reactions tu. Okay, kalau yang ni pula, this carbon radical pair up with the Br, yang ni lah produk yang kita nak kan. Kita dapat kat sini. Habislah untuk this termination step. So bila soalan minta awak buat mechanism of free radical substitutions, awak memang kena start daripada the first step here. Kalau dia ada satu tunjuk kat sini, satu ni je lah awak buat. Proceed propagation step, kalau dia tunjuk dua step ni lah awak kena buat. Bukan pilih salah satu. Okay, lepas tu terminations. Kalau ada tiga ni, tiga lah awak kena buat. Bukan pilih salah satu. Okay, itu sahaja 5.1 alkanes. Habis untuk 5.1 alkanes awak.